So number 3, we have y equals 2x squared minus 8x plus 5. The a value is not 1. Okay, so let's go through the steps. Step 1, as you can see, I already have it written down right there, is to find the vertex. And to find the vertex, you need to use the formula x equals negative b over 2a. So I rewrite the formula with parentheses instead of the letters, and then I'm going to plug in those values. The b value is negative 8, and the a value is 2. So we really have an 8 up on top and a 4 on the bottom. And 8 divided by 4 is 2. So the vertex x value is 2. There's the 2 right there, my x value of my vertex. I need my y value. How do I do that? I plug it in. So I want to take the x value of 2 and plug it in right here and right here. So I want to rewrite this equation down here, but I want to plug in 2 instead of x's. So I have my entire right side of the equation, 2x squared minus 8x plus 5 written right here, but instead of x's I put parentheses. And now I'm going to take the x value of 2 and plug it in to my x's inside the equation. So working this out using the correct order of operations, you do the exponents first. There's nothing to do inside of the parentheses. So 2 squared is 4, and you have 2 times 4 minus 16, because 8 times 2 is 16, plus 5, might as well do this final multiplication, 8 minus 16 plus 5. So we're going to get a negative 8 plus 5. Negative 8 plus 5, that is negative 3. So my y value is negative 3. So there's my vertex, 2, negative 3. So let's actually go to 2 on the x, negative 3 on the y, and put a dot right there. And this is the most important dot of any parabola. It's called the vertex. It's either the highest point or the lowest point, the maximum or minimum value. Ladies and gentlemen, is this a max or min value just by looking at the equation? It's a min value because the a value is 2, which means it's positive, which means it's opening up. And so it has to be a minimum value. After you draw your vertex, you could draw your axis of symmetry. Axis of symmetry is that vertical line, and if it's a vertical line, it has to be an equation that reads x equals. So if they asked you for the axis of symmetry equation, what would it be? So the axis of symmetry equation is x equals 2. You can't just say 2, because 2 is just the number 2. But when you say x equals 2, that's really the vertical line that passes the x-axis at the value of 2. So when they ask you for the axis of symmetry equation, it's not good enough just to write down the number 2. That's just a number. But when they say what's the equation of this line, well, you got to get a variable in there. It has to be x equals 2. Okay? Remember, x equals a number will be a vertical line. X equals 2 is a vertical line that passes at 2. Okay, so bottom line is we need some coordinates, right? And if you look at the instructions that I gave you yesterday, you want to pick some values. How do you find coordinates? You use an XY table, correct? So let's do a XY table. And you want to pick some numbers that are on the same side of the axis of symmetry. So the axis of symmetry is going right through the value of 2 on x. So you could either pick 3 and 4, or you could pick 1 and 0. It's up to you guys. What do you think is easier to do?
1 and 0.
1 and 0. So I'm going to pick 1 and 0. I'm going to go with 0 first because it's the easiest, and then 1. Now, if I do plug in 0, I could actually do that in my head. By the way, whenever you plug in 0, you always get this c value. And if you think about it, when you're plugging in 0, that's really finding the Y-intercept. Because when you say, how do you find the Y-intercept of any equation, you have to set x equal to 0 and solve. So if we were to plug in 0 right in here, there and right there, then you end up with what as an answer? 5. So 0, 5, really easy to do. 0 on the x, 1, 2, 3, 4, 5, way up here on the edge. That's your y-intercept value. That is a coordinate. And you could already map it over to the other side if you wanted to, over here. But I want to plug in 1, and I want to try to do this in my head. Let's see what happens. X squared, that's really going to be a 1 squared. What's 1 squared? 1. What's 2 times 1? Okay, I better not do it in my head. Let me just at least jot down 2. That first, this whole thing is equal to 2. And then over here, what's negative 8 times 1? Negative 8, so you put a minus 8 right there. And then plus 5 at the very end. Okay, so 2 minus 8 is negative 6. And negative 6 plus 5 is negative 1. So we have those two coordinates, 0, 5, which we already graphed, and 1, negative 1. So if I go 1, negative 1, I end up right there. And now I could map them over. Now what do I mean by map them over? This top point is 2 units away from my reflection line, from my axis of symmetry. So I'll move it 2 units away this way. Put a dot right there. And this other one is only 1 unit away. So I'm just going to go 1 unit away this way and put a dot right there. And I am done. Put some arrows on it. You graphed it. Okay, so let's answer the rest of the questions. So we said that the vertex, we found that, was 2, negative 3. That was 1 point. Another point was stating the axis of symmetry. It's x equals 2, and you have to say x equals 2, not just 2. What else? We need domain and range. Let's go for domain. What's the domain of this thing? Remember, domain's talking about your x values. What's your domain? X is what? That's right, x equals all real numbers. Parabolas always go to the left and the right forever. Whether it's opening up or down, they still go left and right forever. So domain is always going to be x equals all real numbers when it comes to parabolas. It's kind of like this. You could even think of it in terms of inputs. Could you, like, look at the original equation, forget about the whole graph. Could you plug in a 0? Yeah. Could you plug in a 1? Yeah. Could you plug in 10? Yes. Could you plug in 100? Could you plug in 1,000? Yes. You could plug in any number you want in here, as long as you plug it into the x into the x and work out the math. So when you're talking about your x values, you're talking about inputs. What values could you actually input? You could plug in any number you want. Okay? Now, let's talk about the range, the y values. Y has to be what in terms of this graph? Remember, y is up and down. So, does this graph have a value at 5? Yes, it does. Does it have it at 3, at 2, at 1, at negative 1, negative 2, negative 3? Yes. So, where are all the y values of this graph? Greater than, and we have to say or equal to. So, we're going to say greater than, well, greater than or equal to negative 3. Now, the reason why we have to say or equal to is because the y value on the vertex really is negative 3. This coordinate is negative 2, negative 3. It actually touches. That's the minimum value. So you have to put the or equal to. If you don't put the or equal to, I'm going to have to deduct partial credit off of that. So please do that. Okay, so that was another answer. It was also asking us for the y-intercept. The y-intercept, you could clearly see that it crosses the y-axis right here at the value 0, 5. Again, from graphing lines, the y-intercept, you find the y-intercept by setting x equal to 0 and then solving. And setting x equal to 0 is super easy because the x's, if you change them to 0, it's always going to give you the c value at the very end. So here's a note you guys could write down. The y-intercept is always the c value. The y-intercept is always the c value. And that's only when it's in standard form. If it's in a different form, it's not going to work. But if it's in standard form, ax squared plus bx plus c, the y-intercept, it's always going to cross the y-axis at that final c value at the end. So just by looking at this original standard form, I could look at this 5 and I could be, oh, it's going to cross the y at 5 and put a dot right there. So yesterday we learned a lot about parabolas that have the a value of 1. Yes? And we had this pattern for the a value of 1 or negative 1 for that matter. From the vertex, you could go, these are not coordinates, it's a pattern. from the vertex. You could go 1 over 1 up. You could go 2 over 4 up, 3 over 9 up. Now, if you look at this vertex, if you go 1 over 1 up, you don't get to that next red dot. So obviously, this pattern doesn't work for equations that don't have the a value of 1. That doesn't mean you can't use it. Technically, you could modify the pattern if you really want to use the pattern. I would just go with the XY table, right? Go with the XY table. But if you really wanted to use the pattern, what you could do is take the a value of 2, and you could technically multiply the y part of the pattern by 2, and you would get your new pattern, which would be 1, 2, and then 2, 8, right? And then 3, 18. If you wanted to multiply your y values by 2, because your a value is 2. Now, if the a value were 3, you could multiply all these y patterns by 3. If your a value were 1/2, you could multiply all your y value patterns by 1/2. I hope I'm not confusing you guys. Am I? No? Okay, so if we did take a look at this new pattern that's been modified by multiplying all these values by 2, from the vertex, if you go out 1 and up 2, you will go 1 up 2, you do get to that next point. If you go out 2, up 8, you go 2 this way, and 1, 2, 3, 4, 5, 6, 7, 8, you really do get to that next point. So it's not that you can't use the pattern anymore when your a value is not 1. You could use a pattern, but you just have to modify it. Now, like I said, I kind of prefer the XY table when I don't have an a value of 1. But you could still use a pattern, but all you got to do is modify it.